Oh, perfect. I saw Mark just joined, so I guess that's a signal trigger that we should get started. So welcome everybody this afternoon to this webinar, Advancing Interoperability and Innovation in Distributed Energy Systems. This is a cluster webinar organized by the projects that are involved in those activities within the storage related call, but also with the participation of INTNET, which is a coordination support action dealing exactly with interoperability. Very briefly, I will not take too much time on the agenda. We'll have an introduction by Mark von Stiphout from DG Energy, and he will talk about the role of interoperability and standardization in advancing Europe's energy transition. And then the idea is to have two different panel discussions that will touch, first of all, the topic current and future use cases. We have Alexander Lucas from Inestec, Laia Gitar from ETSO for smart grids, Abi Nasser from RDUP, and Vieri Emiliani from MAPS Group in this first panel. Then we have a second panel on collaborative problem solving. This will be moderated by Alexander from Inestec. And we'll have again Laia Gitar also for this. And then Abi Nasser also involved in the second one together with Vieri Emiliani. But also we'll have a new contribution from Elisaio Sarmas from the project Creek Valley. And at the end, I will, the last 15 minutes or so, whatever is left, try to summarize the discussion that we had in the two different panels. And now I would like to give the floor to Mark. As we know, the interoperability is now a super hot topic in the European Commission, with the activity also going on for the famous group Data for Energy, D4E. So Mark, please, floor is yours.
Great. Thank you very much, Anto. And good afternoon, everybody, for this Interstore webinar. Thanks for inviting me. Yeah, like Anto said, interoperability is a super hot topic. And for us, I would like to maybe briefly point out why it's so important, with the risk of saying the obvious things. What therefore matters to us in terms of, let's say, the way we fund projects and the way we, let's say, what we expect from them. And then as a last point, how we want to take this work further in terms of going from projects, Horizon Europe, or let's say research and innovation projects in general, to actual market uptake. So first of all, why this is so important. I guess that I don't need to explain to you the issues about integration of renewables, making sure that we are more and more able to make sure that the demand follows the load, that we're moving to basically a weather-driven energy system where flexibility becomes more and more important. This has always been a kind of underlying flow of work, if you like, since I would say 10 or 15 years in energy policy and in the European energy transition policy discussions. And it pops up in different ways and different forms over the years. I think when we were talking about the clean energy package, let's say, I don't know, 8 years ago or so, or 9 years ago, we were very much focused on how are we going to be able to integrate all these renewables, how are we going to promote flexibility. We were talking about network operators procuring flexibility from the system. Which, to be honest, we have seen has not been taken up that much. I think we when we started talking about, let's say, the Green Deal, and when Russia invaded Ukraine, and the whole discussion started around the high gas prices and the subsequent high electricity prices, that whole discussion around flexibility got a new push in the sense of changing let's say, changing the way of functioning of an energy market from consumers just sitting at the end with all their consumption and being a price taker of the wholesale energy market price without having any ability to do something about it, into flexibility as a way to really control your energy bill, and also not just households but also industry. The more flexible you are, the more you can consume when the price is low. The lower your overall energy bill will be. So it also since then has become a key element of all the discussions on competitiveness. But we still have the same issue, namely this, let's say, what technically is perfectly feasible in terms of flexibility of consumption and adapting your consumption patterns, is in practice not really widely used and implemented. We have a lot of smart meters in Europe installed, but flexible energy contracts, let's say people having a direct link with what the wholesale market price does, and also a service linked to it to be able to respond to it, that's not really taken off. Me personally, now living in a new house where there was a smart meter installed, I said, okay, let's switch to an hourly tariff, but no follow-up from my energy supplier around the possible service that they could then provide because I have a smart meter and I have an hourly tariff. I think the maximum they can do is provide me with an app so that I know how to run around the house and when to turn on the I don't know, the charger or the washing machine or the dishwasher. So and I think one of the key issues why this is not taken off is because of the lack of interoperability of easy implementable solutions that make all these devices or actors talk to each other. I think the network operators with the energy suppliers, they communicate on a lot of things, but having the devices in between, the distributed energy resources, all the energy consuming devices, and actually adding that up to a service is not really happening. The communication between the meter and the heat pump and the charging station in a household, for example, if you want to make that work, it takes a lot of time and effort, whereas all these things are equipped with smart communication tools, but they all go into their separate channels of communication. So it is super important for competitiveness, for integrating higher shares of renewables, for keeping basically people on board for the energy transition, because people have been informed about the energy transition is not just good for the environment, it's also bringing more renewables to the grid. Renewables are cheaper, but at the same time, they don't see anything of that. They are takers of the gas price without any options to do something about it. So we are not there yet by far, and this is, I think, what we are on the one hand trying to promote with research projects like Interstore and like many others, and that also Anto just mentioned that we are trying to put together through Intet. We have had all the technical projects, so to say, that tested what type of flexibility can be provided with what type of devices, how can network operators work together in order to give signals, how reliable is using all these distributed devices to keep either the frequency in the system or to solve congestion management. All these projects had very, very positive results in terms of technically all of these things can work perfectly well. But then turning that into practice is still a big issue. We have through our is a big issue, and one of the key issues there is the interoperability and the easiness with which you can exchange data and link all these different devices together. So more and more we have shifted our Rise in Europe program to address that type of issue, both on the network operator side, but also on the devices side, and bringing more and more of these parties together, while continuing to look for showcases and easy use cases, for example, communities, for example, local storage solutions, etc., to see what can be the, let's say, the first market for these type of things where it's worth investing in this. And I think that now it is also the right time to turn this into a real policy measure, having had all the experience from projects like yourselves and the other projects that are combined in INTNET, in terms of making recommendations of how the data exchange should work, what is required to make the interoperability work, had the blueprint that that INTNET, with input from many different data space projects, has been working on, is how do we make this really the common approach around Europe. And of course here, the data exchange in a way is again, if you like, at the end of the pipe. There is if the network operators, for example, don't give signals on where or when there is a need for a frequency response, or where there is a need to do something about congestion and give a value to it, then there is no incentive for anybody to invest in a service that can make that happen. And at the same time, network operators need to invest in making these things possible. But the let's say the traditional, or also the way the regulatory model is set up, still has a bias towards CapEx over OpEx based solutions. Making these OpEx investments is very often an uphill battle, for which the outcomes are uncertain or difficult to prove because there are no offers. And so it's also a bit of a chicken and an egg problem of who makes the first investments. And we see, for example, in the Netherlands that for a long time there is no business case, and then all of a sudden there is a huge business case to invest in flexibility, but then setting up the system takes too long. And then we are back into investing in let's say the blunt big hardware solutions, like building big batteries somewhere along the system. The only let's say good thing to come with a bad thing in the Netherlands is that the solution is so huge that they have to do all of these things, and that even the quick fixes don't fix everything. So they also need to look at promoting much more the use of flexibility and making that much easier. But I don't think this is the example we would like to see in other places. We would like to avoid it by having these advanced discussions. And that's again where projects like Interstore matter so much, not just showing that it's technically feasible and how it can work and how it can be rolled out at a wider scale beyond the project, with addressing the interoperability and the standardization, but also showing concretely what the benefits are, giving experience to the regulators and the hands-on evidence, as well as to the network operators, to say these invest it because they are relatively low compared to the damage you can run into when we are too late. So this is for us the key issue around the projects, and also why we're asking them to cooperate through Bridge, through INTNET, etc., and why we are always looking for this type of evidence and examples. And why we also want to support you in bringing the message to the regulators, to the network operators, etc. And at the same time, we're bringing that further now, like Anto said, with the D4E work. So under the whole digitalization of energy action plan, data exchange is one of the key issues. Make the data exchange easier for all these innovative energy services, in particular flexibility. And so in the D4E group, we have brought together all the key players, including those who have the experience from the projects, to say, how do we now make this a European way of data exchange? We have pretty quickly realized that there is a big, let's say, parallel world, which is the automotive or the transport world, talking about smart charging. So I'm actually spending a lot of time now integrating different work streams that are run in different places in Europe or in the Commission, like the Sustainable Transport Forum, the Coalition of the Willing on Bidirectional and Smart Charging in Germany, as well as our D4E work. And the challenge there is really to come up with a common model of how flexibility and smart charging works, so to be able to come up with a common way of the data exchange, so to be able to see what things need to be interoperable where, what do we need to standardize, where, let's say, where do we have too many standards and do we need to give big priorities, and where do we not have yet the standards that we need. And so this is basically how we are spending most of our time at the moment. This is now very much for flexibility, but it's also very much important as we are talking about, let's say, the next revolution or the ongoing revolution with the use of AI in energy, which we think can really be a factor that can help the energy transition. But let's say each individual party in the energy sector, each business, does not have enough data to properly develop the foundation models that we need. So this whole data exchange discussion that was started and is really necessary to make flexibility work and to make the integration of renewables work, to make the competitiveness, let's say, competitive energy supplies to the industry possible, is now also becoming a question of how can Europe perform in the, let's say, in the AI race, and how can we make sure that we use AI also for the energy transition and use its potential and not, let's say, miss a huge opportunity there. So I hope this has given you a bit of an indication of where we're looking at and what we expect from you, and also that this means that you have a big responsibility in contributing to solving all these issues. You are not alone. I think that is the good news. And let's say, if and where we can support you in doing your work better, please let us know, because that is also in our interest. But there is a big challenge, and I hope that with Interstore you can contribute to solving a part of that puzzle. Thank you.
Thank you, Mark, for a very comprehensive talk. Very interesting, with a lot of points that I think will sparkle discussion later into different panels. Thank you very much. You're welcome to stay with us if you have time in the discussion. And now we can move to the first panel. The first panel discussion is about current and future use cases. I will be moderating and then giving the floor to our fourth presenter, Laia Gitar from Mezzo, Vieri Emiliani from MAPS Group, Alexander Lucas from Inestec, and Abib Nasser from Redupe. I would like to start asking maybe each of you briefly introducing just 2 words yourself and how you fit in this discussion of interoperability. What are the key points that you will like them to bring up for the discussion, following the picture with Laia?
Yes, good afternoon, everyone. My name is Laia Guitart. I am a projects and policy officer at EDSO. I have been working in internet, and I would like to bring the perspective of policy and regulation and how are they very relevant to enable interoperability in today's discussion.
Thank you. Vieri?
Thank you, Antonella. Vieri Emiliani, Head of Innovation in MAPS Group. I'm a physicist by education, a computer scientist by passion and experience, a long experience. So, and I'll try to bring the point of view on interoperability of a computer scientist and of a player of the energy sector as a software and solution provider, and what are the good things that we see and the issues we foresee, hopefully helping the discussion.
Thank you. Alexander?
Hello, good afternoon, everyone. Glad to be here. Alexander Lucas from Inestec. I'm leading the area for demand-side energy management. And the topic of interoperability is very dear to us. I mean, we've We've been dealing with this since FP7 at least. But we've had projects such as the Intergrid. We coordinate the the Interconnect project, and we found the relevance of interoperability in many aspects, and we continue to find them. Now, for example, with data spaces. So it has room in many domains. This is of huge interest to us. And so I'm looking forward to having this discussion.
Thank you. And last but not least, Habib.
Yes, thank you, Anto. So I'm Habib Nasser, CEO at RDAP. We are located in Paris area. And we are partner in FlexChess EU project. And we are developing mainly digital tools. And we are testing our software. For example, for hybrid energy storage system, for energy communities creation and management, and also for distributed energy. And I'm proud to contribute in this webinar through our experience on the different EU projects and the energy products and grid needs. So thank you.
Thank you. So let me start. So the topic here for the first one is current and future use cases. And I'd like to start with Laia, and how you see then the EU-funded project enabling cross-domain interoperability exchange, how it connected also with the policy aspect, as you were saying.
Yeah, thank you so much. So EU projects are, of course, a key enabler of cross-domain interoperability, because they do provide a unique platform that brings together all the relevant stakeholders. They do allow for the testing and validation of interoperability concepts in real-life settings, and they also help to establish consensus for EU-wide replication of best practices, and they also ensure that sector-specific requirements are considered in the design of interoperable solutions. For instance, in our case, we bring there the perspective of DSOs, which are quite impacted by this. In Internet, for instance, we developed 5 cross-domain use cases. We worked in EV charging, flexibility management, energy communities, a smart meter integration, and also renewables operation and maintenance. And beyond the projects also, as Mark was mentioning before, we have broader initiatives. We have a bridge that also enables these cross-domain exchanges further. For instance, Internet Colette Action 4 on sector integration, and supported the synergies across 18 EU-funded projects on that would focus on energy sector integration. And I think that this is where projects play a key role.
Thank you. I'd like to continue going around, and I'll be back to you. I was very much really intrigued by your first statement. So the role of a software engineer in this discussion. Could you maybe elaborate on your first statement? I think that would be a really interesting point. We are mostly energy type of people here. Now you come to the software perspective. That would be
well. Okay. Now interoperability. Currently, we do not have big issues in having energy system operating per se. The problem is that as Mark mentioned, when we try to make system operators have quite a well-structured way of communicating and exchanging data. In fact, we have a quite stable system in spite of the addition of renewable energy sources, at least, let's say. The fact is that now the problem is that having communication and data exchange, reusing Mark's word, hopefully properly, and this is quite more on the data itself, the problem itself of data, of the modeling of data, and how we manage to make those information available for machines, which is the issue we have now. But the problem is that I can have different devices, and each one is using its own, often proprietary protocol, and so it's very hard to make all these different devices made by different manufacturers using different protocols, different data models all together. And this is more an IT problem and a data engineering problem rather than a specifically energetic issue, in my opinion. That's what I meant.
Sure. I would like to follow up on this and asking you mentioned protocol, you mentioned data models. Another relevant topic that in projects you hear a lot is ontology. How do you see the role of ontology with respect to data models, and how critical will be to, for example, work all together on a single ontology? We had the discussion in the last meeting of Bridge. Should we try to develop a mechanism to work together, or in a common initiative about ontology? Do you see that as a critical component to build this interoperability?
Okay, I first of all, I'm not here as a paladin of ontologies, not at all. I know their limitations. They are still find hard to get traction in the industry. Adoption is not as wide as it could be. The tooling around them are clumsy, and they're not easy to understand, nor for computer scientists and software developers, nor for domain experts, which are the other side that are badly needed. Yet, despite all this, they are still the best tool we have for representing knowledge in a machine understandable way, so that machines can exchange also not only the bits and bytes of the data, but also the semantic and what each element, which data we are exchanging is representing, and what are then describing the capabilities of the asset and so on. So I'm not saying we can use any, again, we can follow, agree upon any standard. We can use ontologies or use a different technique, but I don't think it's a technical issue. It's more, it relates more to agree upon some logic, some ideas, some concepts, and especially rules. So in a way, I think that as we already mentioned during our discussions, previous discussions, I think, for instance, the JRC Code of Conduct is quite a good example for energy smart appliances. It's quite a good example. It's not trying to describe every single aspect. It's just focusing on few elements for enabling flexibility. It provides strict rules, voluntary rules, for the device and the manufacturers that want to adhere to the framework, and reusing existing ontologies, namely the Serif family. So, Antonello, I hope I answered your question at least a bit. It's not a matter of the technique, it's more about agreeing upon how we want to exchange this data, and probably enforcing or incentivizing frameworks and that somehow push the different actors and stakeholders to adhere to those mechanisms. Ontologies are just a tool, again, a good or bad, a tool.
Okay, no, thank you. That's very good analysis. Alexander, I would like to now move to you. in relation specifically to the Interstore project, Interstore took a kind of a strong decision to focus on IEEE 2030.5 as a way to build interoperability, introducing also the legacy converter. What's your experience in terms of applicability to different use cases of such an approach? How do you see that after the experience of the project? Was that a good start as a decision? How do you see that? How would you comment?
And thanks for this, Antonio. So maybe capturing and leveraging on the previous comments, I think we've addressed two elements here of interoperability, the semantic interoperability and the syntactic interoperability. And for sure, there could be use cases for both of them. So for the wider audience, I mean, syntactic interoperability in the way that we have a common form of exchanging information. And when I mean semantic interoperability is that we have the same understanding of that information. And so here we can see that there are two approaches, a dictionary-based approach where we ensure the syntactic interoperability, and then your system is responsible for understanding and using that information that you have shared. And then there is another approach, the ontology, the semantic interoperability. And here, it's not so easy to find use cases in this, where the reasoning exists, the reasoning need. But I would like to have Yeri's comment on this. For sure, there are some use cases identified. It was not the case in Interstore, to respond to the question. In Interstore, we found a challenge, which was the integration of distributed energy resources. We had different, so it was one of the pillars in the project, hybrid energy storage systems, but we had there also charging stations. We had different inverters. We had inverters from PV panels. So we had several distributed energy storage systems. And we, in the course of the project, we had to implement a data space, which is yet another element here in the discussion being tackled by many groups. And so this is when we came across of the need of speaking a common language, of exchanging information that one can understand, in the sense that the variables come in the same way, they refer to the same units, they refer to the same labels. So if I'm talking about active power, it's active power, I know what it is. But we didn't have the need for this reasoning, as I understand it. The goal here was to have these variables being exchanged. We came up with several valorization cases. If I refer to the data space again, we developed four or five valorization cases. And so here is where we saw that, wait a minute, I'm getting some data sets in Spanish, other data sets with the labels in Italian. Some refer to power as P, others with active power, others with in kilowatt, others with watts. This is a mess. We have to agree on the data format. And so the challenge in our use cases, and so we have 9 demonstrations, 9 use cases, and this was common to all of these use cases, the need to integrate different data sources that come with all of these different distributed energy resources, and to have them read by a common higher management system. It could be a battery management system, a home management system, building management system. So this was a challenge. So for us, we saw that the challenge was we need to set up a common dictionary, which can be hosted directly in the asset itself. And so it's the IEEE 2030.5. put forward by the IEEE. So there's a version from 2018 and a renewed version in 2023. But this was not enough, because we want another pillar of the project was flexibility and service provision to the grid. And so we need fast response, something that the original IEEE 2030.5 could not deliver, because it's based on a REST API communication, which is a synchronous way of exchanging information. And so in the project, we developed, we implemented a NATS communication. It's something relatively new, which enables very fast asynchronous communication. So we're talking about below 100 milliseconds. And so here, in all of the use cases that we've developed, we were able to reach this type of interoperability, the one that we needed for distributed energy resource integration. Fast, asynchronous, and above all, many-to-many communication, which is particularly important when you have a horizontal structure or relationship. So in other types of communications, we have a more hierarchical structure where we have a higher entity responsible for managing all the assets, or a master-slave relationship, as in Modbus communication. And here, if we agree and if we talk all the same language that the master imposes, we are fine. But the challenge here, when promoting the many-to-many communication, is highlighted, and we achieved this with the IEEE 2030.5 Interstore version, which, by the way, for the audience, is made open source, available in the project GitHub, all the developments that we've accomplished in the project. So to come back to the original question, it really depends on the use cases that we have. If we need semantic interoperability, so full interoperability, or syntactic interoperability.
Thank you. I will just, I like to keep the dynamic. Sorry that then I will move also to a bit, but I would like to come back to some of the comments you made. And so this idea of a dictionary, so then the computer science, don't kill me, then simplify means data model will be enough, in my simplified version. But my impression, for example, when I work in other projects, is that when you cross to, and that could be also maybe later a bridge to buildings, for example, and then we are leaving the comfort zone of the electrical, that's where maybe dictionary will be too hard. Vieri, would you agree? Is that maybe a direction to explain why, this term of ontology comes up, and could be the way to, the more, maybe I'll try a statement and you tell me if you like it, the more interdisciplinary we get, the more we will leave the comfort zone, and we need something more sophisticated. And that's where maybe ontology may have a reason.
This is what we did in Parmenides. It's just a very quick example.
Perfect.
The idea was to have this hybrid energy storage model as an archetype for different type of storages. So, for instance, if you take a battery and an electric boiler, okay, and you model the different properties of a hybrid energy storage from the abstract perspective of a storage. So it has capacity, it has state of charge. Now, for a battery, this is almost a one-to-one. But for the electric boiler, we need to resort to physics. We have to define, okay, what's a thermal capacity? How it translates in terms of state of charge. And if you use ontologies, you can represent those two completely different natures under exactly the same concepts, so that once the EMS needs to understand, okay, how much capacity do I still have? I've got excess generation, can I store them? The battery is full, can I use the electric boiler? We don't need to implement specific reasoning. It just can be inferred from the common representation of the storage and how the different these properties translate to the actual sensors and actuators of the two different devices. This means this is a use case where vocabulary may require a specific implementation with the EMS, within the EMS code, which is perfectly fine, perfectly, but it doesn't scale. If you add different devices, if you have different technologies, like the thermal building, the thermal inertia of building, on that we had electric vehicles, etc., then it may be very challenging to decline the idea against all these nuances, while having a common semantic model helps the reasoning and ease the process of using and managing, adding okay, in my opinion, using ontology under this use case adds a degree of freedom to the system. So it can provide more flexibility and it can easily scale. I'm not saying you cannot formalize knowledge under using a different formalism. I'm just saying that that's a formalism we used, and reasoning on that, it's really valuable in terms of combining, defining rules once and apply those rules to different devices, different energy vectors, and different technologies. Does it make sense, Anto?
Yeah, I like it. Maybe then I will use this as a bridge to go to Habib. And I know you're focused mostly on energy community. How would you link the discussion we are doing right now to your experience related to energy communities?
Okay, thank you, Anto. I think that I will join speakers that there is many, we can say, features are needed for energy communities that can support, for example, distributed energy resources or energy products. Mainly, we have interoperability, we have the aggregation, we have security. So as indeed, so I think there is a strong connection between the two domains. And as you know, there is a lot, we can say, various software or data-driven software that developed in the last years. And the idea is that the energy community are almost distributed, and so their assets and the energy system. So by creating energy, the new, we can say, as a new use case, energy communities implicitly will involve theirs and will foster the participation in energy serve. And as in our case, for example, we are developing within Masterpiece project a new tool is called eCoop, and it will be used, for example, in FlexChess in order to create chess community. And based on our experience, I think this software can support the DERS integration mainly by de-risking and facilitating the aggregation, because there are a lot of distributed assets. And when, for example, a member joins an energy community, he will come with their assets, with their distributed assets. And these tools will be, I think, a potential tool and way in order to aggregate these assets or these distributed assets in order to act together at the same time, like one virtual, for example, energy storage or energy system. And I think that as energy communities is like an exercise, is a good exercise for example, for distributed energy resources, because it needs affordable and interoperable digital services. So here I join speakers that interoperability is required for theirs to enable real-time, for example, monitoring and management of distributed assets, such as, I don't know, for example, solar panels or hybrid energy storage system and EV charger and EVs, whatever. So, and I think also here I want to add that, to highlight that the strong security requirement by the energy communities management and creation is also beneficial for the provision of energy products and the integration of theirs. So I think, for example, for the second point of energy products, these kind of services or this kind of software, digital software, including, for example, our tool eCoop, it enables the creation of local energy flexibility services, and it will allow to disrupt the marketplace, for example, by using a DLT, providing, for example, token-based energy credit system, and to incentivize and motivate members in order to join EC. And more they have energy access capacity, more they will be rewarded and tokenized. And I think here my key message is that this data driven, because it is based on the exchange and fetching data in an interoperable way that is dedicated for energy communities, can offer a great replication for theirs, and can offer can foster the active participation in the energy transition. If they are, for example, the main point, they have to be intuitive for end users and interoperable for the communication of information layers, secure and affordable. So they have to be accessible, I mean, for energy, for members that they have low resources in order to spread the use and the involvement and integration of theirs. So that's the main point that I can provide for this discussion. Thank you.
No, thank you very much. We're getting already over time, but I would like a very quick final question for Laia, if I can, because I think with Alexander we mostly focus on the aggregator type of work. Then we talk about the energy communities. I'm missing the grid operator point of view. If you could maybe, if you want to add anything to the discussion, particularly also after what also Mark said in the beginning, bringing the DSO perspective in this discussion.
Indeed.
Just to close.
Indeed, thanks, Anto. I'll try to make it quick, but I wanted to start by sort of saying that we are very much aware, or DSOs are very much aware, that the data exchange between them and the consumers is essential to support this energy transition with the consumers at the center. It is essential for them to send price signals, etc., etc. So they play a crucial role in achieving interoperability, and because of this, the importance of their role, they must engage in interoperability initiatives to support the energy transition in an affordable and efficient way. So when considering, for instance, their role on standardization, I think that distribution system operators can lead by example. They can adopt open and cost-effective standards over proprietary solutions, for instance, which is crucial to promote EU-wide interoperability. They can also contribute to, for instance, drafting the network codes, defining the rules, and this interoperability at more functional business levels, referring to the SGAM now, if I may. But I think it's also important to think that developing standards is not part of the DSO's core businesses. It is not mandated by any directive. So it is, as Mark was saying earlier, there is sometimes this limitation, because we know that we should invest in the solutions, but then regulators might not authorize the expenses. If, for instance, a DSO wants to lead standardization, for instance. And it's also, we need to also to consider that we have a lot of legacy systems, and that transitioning from these proprietary systems that might be there can be costly. And this is also that we also need to consider, because we need to keep efficiency at the end. However, since the result of all this will be consumer empowerment, a most effective grid management, and so on. I do think that engaging in all these interoperable initiatives is, and leading by example, is a role that DSOs should develop even further. I hope this answered your question.
It definitely does. Thank you very much. And yeah, I'm already over time, so apologize with the panel discussion number 2, actually to Alexander. And thank all my speakers, and I would like to give the floor to Alexander to start immediately the second one. Thank you again very much.
Thank you so much, Antonello. Well, for the second panel, we have a huge addition. We have Eliseo Sarmas from NTUA. He's the responsible for the project Crete Valley. And well, we would like to touch here in this discussion on different points, but I mean, unavoidable, we cannot forget what we've said just before, and there is a connection already to something what we've said. And Vieri, I would challenge you to comment here on some of the things. So coming back, so don't take me wrong. I'm not. I am not an naysayer of ontologies or of semantic interoperability. What I think is that it could be designed most often in or mitigated with a different architecture. So just a comment here. In the case of the boiler that you were explaining, yes, for sure, I see the semantic part there, the reasoning part, the reasoning part, which is a system that is requiring a temperature, but well, it could be applied to this. If I'm requesting something in centigrades, a temperature, and it doesn't have it, it might retrieve it in Kelvin or whatever it has. Maybe it could be a similar reasoning example. But here there is a request from a higher entity, and in the interstore approach, what we have is a many-to-many communication where I broadcast what I have. I broadcast my measures, and there is a common understanding if everyone has access to this dictionary. Of course, it doesn't have the reasoning part because everyone understands what it is. Now you can argue, okay, but how does it have a boiler modeled or in the dictionary? Probably not. It would have to, we would have to add to the IEEE 2030.5. And my question is the following. The same happens to ontologies. Why do so many research projects end up developing new ontologies instead of using existing ones? The floor to you. You
Maybe I should unmute. Yeah. Well, as I first of all, as I mentioned, I just want to make it very clear. What you did in Interstore, it's amazing, and as I mentioned, there's nothing that requires any specific technology. Additionally, modeling knowledge is usually, for a domain knowledge, is usually complex and honestly quite often is very opinionated. So when that's how it ends up. It ends up that even if we agree upon most concepts, the point of view, my point of view may be different from yours or Anta's or Laia or Abib or Elisai's. We will provide a different definition because the wider is the domain, and the more challenging is to come with a proper definition. So my suggestion, in a very short example, would be that we focus on what is required to implement that specific use case. Is what I call use case ontologies as compared to domain ontologies. Let's leave the domain ontologies to the academic research. There have been quite a few projects that were founded to provide interesting models. I think there are around, Saraf has got a lot of work done on that. There are other approaches like the brick schema that's more focused on building, and sooner or later, so everything, they're all fine. At the end, we have to implement use cases in a way that can be used by you, by me, by everyone, okay? And it's not relevant what kind of model, what nuance of the domain knowledge we use. Let's agree. It's like communication standards. It's like syntactic interoperability. It's like communication interoperability. In order to become interoperable, we have to agree upon it. And it's not important. It could be what the musical instrument industry did in the 80s with MIDI is a fantastic example. If you were using Roland in 1979, if you were using a Roland synthesizer, you were stuck to Roland. Then you had to have a Roland drum machine and an electric Roland electric piano if you want to play them together. Then, same for Yamaha and any other manufacturer. But at the end, they specifically, I would say, Roland took the stage and proposed an open standard, MIDI 1.0, that was 1983 probably. It was hard, but industry agreed upon that protocol. It's not the best protocol ever. It's been around for 40 years. So it doesn't have to be the best language. Let's define one language. Let's use one model. It can be, ontologies may help reasoning, yes. The battery and boiler use case, so if we have to mix different representation, different vectors, yes, it could help. I don't care. Let's just agree upon something and start using and let's make it the standard.
Jari, thanks for this. I'm just mindful of the time, but let me take another question for you. So if we agree that we don't need perfect standards, but a shared commitment, then who should lead the process? Industry.
Okay, I think somehow we already had bits and bytes of the answer from Mark and Laia as well. So in my opinion, for sure it is a shared responsibility, but it cannot be diluted. So regulators and EU must define the standards, must select the standards and incentivize, make them mandatory, but enforce the adoption of standards. DSO, energy, industry big players shall, as Laia said, shall lead by example, adopting the standards. And research projects or researchers shall, in my opinion, provide the evidence to the EU and regulatory agencies to take informed decision by testing, as you did, and providing evidence of the value of different options that we have on the table. Yeah, that's. I think that's a way. It should be. That's how it should be, at least from my perspective. I don't know. I'm curious to hear other panelists' ideas and opinion on that.
Thanks so much, Jari. Yeah, Habib, yes, you'd like to come in?
Yes, thank you. Just one comment. I think the existing ontology are for me, I think, are almost domain focused. framework. So they cannot cover cross-domains use cases, novel regulation, and even new or complex industrial use cases. So what we should do, maybe we can try to extend what exists as ontologies, or if they are not extensible or interoperable, so we should to create new or establish a new ontologies. But who can lead? I think maybe here we need a co-creation approach. So maybe an expert of each domain can contribute in order to elaborate this kind of new or disruptive ontology. That's what I can contribute to.
Thanks for this, Abi. Well, I would like to give the floor to Elisaias, to share his experience, especially from Crete Valley, which is also a very sound project that has been around for quite some time now. We've seen Crete Valley in different stages. I think we were together in Enlit. You were there also with Crete Valley. So, Elisaias, how does a complex project like Crete Valley, with many different renewable energy sources, assets, deal with interoperability with regards to the different data streams?
That's a very good question, to be honest. First of all, I'm really glad to be here in this panel with all of you, and I would like to share a little bit my experience as a more technical guy, not on the energy policymakers point of view, but yeah, certainly interoperability in distributed energy systems isn't just a technical requirement as we tend to see it, but it's strategical a necessity in order to facilitate all this transition. And in our project, Crete Valley, we try to combine different renewable energy sources. We have technologies like solar energy, like wind, biomass, batteries, infrastructure, and e-mobility also with vehicle-to-grid schemes, and even hydrogen. So as you may can see that there are different data formats, different communication protocols between them, and the system risks becoming fragmented, both technically and institutionally, is quite large. So from the governance perspective, we must address these challenges. And the main outcomes that we have been able to see in these first years of the Crete Valley project, which by the way is a 5-year project, and we are now at the middle of the second year, I see 4 pillars. First of all, we must have common and open data standards. Secondly, interoperability can be also part of the licensing requirement. Thirdly, there is a need for national digital energy platforms to enhance all the data streams coming in an interoperable way. And fourth, capacity and upskilling building is very important. So, coming one by one, the common data standards. One of the biggest enablers of interoperability is the adoption of open protocols in the communication domain, like EIC 61850 or OpenADR, for example, with shared data ontologies. So that's something that we try to integrate in these projects so that regulators can even mandate or incentivize their adoption. We have together with us IPTO, the Greek TSO, and HEDNO, the Greek DSO, which help towards this direction. Secondly, the licensing part. Projects receive public funding or seek grid connection with the national grid. It should be required to demonstrate compliance with interoperability guidelines, not just technical compliance, but also semantic. And a recent example is the cutoffs now in generation, in PV generation. Do you know how these cutoffs happened? The electricity system moderator here, operator in Greece, HEDNO, was sending text messages in the cell phones of the operators, and they went hand by hand and they were shutting down the plants. This is not supposed to happen in 2025. So government should support the creation of open, federated platforms where distributed energy resources data can be securely shared across stakeholders, and also controls should be imposed. Finally, the capacity building part. This shift requires equipping system operators, but also municipalities, energy communities, all the people working on that with the knowledge and with the tools to demand and to manage such interoperable systems. So I've touched upon several things that we've seen in our project, but I think each of these things has its slight importance into advancing complex systems and different res assets. Thank you.
Yeah, thanks, Lisa. Well, maybe I jump to Leia because there was also a question, maybe unanswered, that I posed to you. So who will implement these standards?
Yeah.
And how can we ensure widespread adoption? But Leia, maybe she has a different perspective. What do you think, Leia?
Actually, I would agree with what we said here. So implementation will, of course, fall to market actors, solution developers, and in my opinion, the widespread adoption depends on clear policy signs, involving all stakeholders when designing the solutions. And I also think that there's a role to play by EU-funded projects, honestly. But of course, there is one point of controversy we were talking about, for instance, mandating solutions. This discussion I've heard multiple times, and I think I would sort of avoid mandating always, because this can be really expensive and can be at odds with innovation and with technical evolution. So I would say mandate when it's appropriate and foster where it's possible, if you know what I mean. Because otherwise, I think it can be a blocker more than an enabler.
Yeah, thanks for this, Leia. Well, maybe also in this with this note regarding costs, Habib, I would be curious to see. I mean, with your experience in the project that you've been involved with, how can distributed energy resources and energy products reduce costs while ensuring this equitable access?
Yes, thank you for this question. I think as in connection with my first answer about the energy communities, so don't forget that community ownership of theirs enables collective investments, so which allow to share costs between members and also to share the benefits or values generated through via the distributed energy resources. And flexible, for example, flexible energy product like a time-based tariff or energy credits empower users to manage their consumption and earn the rewards to, for example, for contributing to grid stability or resilience. And for example, we have in Flexias, we have use case implemented in the Slovenian pilot with a local DSO, Electro Ljubljana, were distributed. For example, here we consider EVs as distributed energy resources and chargers. So EV communities are rewarded based, and their energy bill is reduced if they provide flexibility service where and when it is needed by the grid. So here, for example, what we are using smart charging, V2G. Our future, we have some future for reservation. For example, if they change their reservation based on the needs of the grids, where flexibility is needed. So at the same time, by generating, for example, electricity close, because this distributed energy will allow to generate electricity where it is needed and where it is used by end user through, for example, I don't know, distributed solar panel, batteries, or microgrids, and which will allow to maximize or minimize the transmission losses, ensure low grid dependency, which allow to enable local consumption and a real access, because distributed will allow to reach these end users that need electricity. And all these mechanisms will promote energy availability by making the energy provided or generated cleaner, affordable power that is accessible to all of them, all of stakeholders, including low incomes and vulnerable groups, for example. And so we can say that based in our last use cases implemented in Slovenia, so rewarding and reducing the bills of, for example, EV charging session will be enablers and a good motivation for them to use their we can say to integrate and involve that there's in the whole ecosystem. So that's all.
Yeah, I think now you lean a bit more towards the energy services themselves, but yeah, I mean, well, a connection element that I may propose is AI driven services, and so we've seen many now in our projects. We have not only traditional AI but generative AI in developing digital services in energy. So maybe just to give a bit more of a floor to Elisaios, I would say, Elisaios, what have you found, the experience that you've been having for the existing projects and upcoming projects? My question is, how could AI or even generative AI enhance the interoperability and semantic enrichment in the energy sector? Also, if I may, just a brief note as introduction, we were discussing about the reasoning part and the generative AI. We have AI providing reasoning as well. So at least this could facilitate, don't you think?
Yeah,
Is it a replacement or complementarity?
Now you're opening a very hot topic. As you know, there are many discussions around generative AI. Both TipsNet and even Bridge are assessing the role of generative AI now, and generative AI can act as accelerator in interoperability. So not replace efforts that are made until now, but can particularly give context where legacy systems, vendor lock-in, and fragmented data pose barriers. So, in fact, we have been starting working in generative AI. We have started working for semantic mediation. So, for example, different systems might refer to the same asset or to the same process in different ways, and generative AI models can analyze, they can align these mismatched terms and structures, effectively acting as a translator in real time between different energy platforms. Second thing is schema matching and API generation. So instead of manually integrating different systems and trying to make them interoperable, GenAI can assist by auto-generating data schemas, semantic mappings, or even the software itself that bridges proprietary APIs, especially valuable ones in the public sector. Even the last part is forecasting and coordination. So as you know, AI can enhance grid resilience by giving us predictive models of renewables output, consumption patterns, and demand side flexibility. And many times the forecasting models themselves are not interoperable with each other. So GenAI can help also in this part. From the governance angle now, the key is to embed this transparency and this explainability in what we call accountable AI. So to be able to interpret what the model gives me. So this is a relatively new low TRL sector, but I think that in the next couple of years, it's gonna be a very, very hot topic, and the maturity will very, very quickly adapt and provide products that will be really helpful for manufacturers, systems operators, and even regulators, I think.
Yeah, you were referring to the prescriptive part.
Yeah, of course.
Yeah, for sure. Yeah, Vieri, I would be curious to have your opinion on this. Do you think generative AI will be a replacement? or is it complementary?
No, I agree with Elisaios. So far, I think that the role of generative AI in supporting the alignment process, I wouldn't say real time, not because it's not possible, but because it's not required. Because once we have the understanding of what is there, we don't need to, we just have we can find a good representation. But I completely agree. That's these new models, the generative AI models, are very good in aligning with context. So I think that again we are living a great moment. We have terrific opportunities. We should decide what we want to represent and how we want to exchange this information, and then those tools definitely will help in mapping from legacy system, different protocols, different standards. But yes, it's an opportunity. I'm not saying for on this, completely agree. On reasoning, I mean, I don't know. I don't foresee at the moment. I don't foresee the necessity of using. I mean, the process we are trying to describe are quite well defined and predictable. So, but I guess in trying to make some, try to get some order out of the data that we have, that would be totally helpful to use this kind of AI models, and also the impact on explainability is and transparency. It's limited, so it's quite a low-hanging fruit.
For sure. Yeah, thank you. I agree. Dear colleagues, I mean, I would leave the mic open for the rest of the afternoon for us to keep discussing this, but unfortunately, we have a timeline. So I just want to thank you for being present, and it was my pleasure to moderate this second panel. And I will hand the floor to Antonello Monti again to make just some closing remarks. Okay, thank you. Please, Antonello.
Yeah, thank you, Alexander. Yeah, thank you. Quite a challenging task, I would say, because the discussion was very, very interesting. I tried to keep track of the different points, and so I'll try now in the next few minutes to come up with some conclusion. I would like to start with the fact that Mark, at the very beginning, put down some very important topics on our table. And basically, I may try to summarize saying the projects like we are involved have been showing what flexibility can bring, but his concern is that we didn't experience so far, even if it's quite some time we are working on the topic, a real market adoption of these different solutions. And Mark pointed that it seems to be that the key element in this is exactly the interoperability. So the topic we are discussing today, and that's the topic also behind a lot of the work in the projects that are involved here, is not a minor, it's actually a very hot topic. And Mark pointed out that solving this issue is critical for the competitiveness of Europe. So this is not a small statement that he made. And that he experienced that also personally, that the offers are from suppliers are not there, are not in line with the evolution that projects have been able to reach. And at the same time, also pointed to some limitation in the regulatory framework that is not helping, because still somehow they are too much capex oriented, and that is creating what he was referring to as a chicken and egg problem. And then the effort now the Commission is doing is with following the action plan to try with the expert group, in particular the data for energy, to address those issues. But I would say it was relevant that he mentioned that actually that opened up new challenges, because it turned out that there are parallel worlds, as he was referring to, in particularly talking about the car manufacturers and what they are doing. And I think there was a very good introduction to our discussion. And in our discussion, I would say there was a recurring question about what are the real targets that we want to achieve interoperability. They can be semantic or syntactic, which means that we have a challenge on agreeing on protocols, but also in the data representations and how we reach this interoperability in data representation. In my understanding, listening to the two panels seems to be one of the hardest points. And we have solutions that are working. For example, Alexander was talking about is a dictionary-based approach with a centralized dictionary that showed very good results. And then the challenge that we were saying is, do we have a limit in this approach or do we have challenges? And then we had a lot of discussion on, could ontology be a tool, will help, would it work? But also there we find challenges. I liked what was mentioned, that the risk even there is that while we're trying to solve a problem, get into another infinite discussion on what ontology are we talking about, because somebody pointed out every project is defining a new one. And then the idea to have something was more use case driven and less focus on domain. But at the same time, we were saying the challenge is to go across domains. So you see that is not an easy task. And basically, the wider the domain, the more complex is to find a solution. And actually, flexibility is about going across domains. And it's probably the explanation why we are in this discussion finding hard to have an overarching solution, because the problem is actually way harder than what it may look like at the beginning, because you're bringing a different sector, a variety of use cases. Just think about the fact that only Interstore, as Alexander mentioned, was covering 9 different use cases. So we'll have 9 different scenarios only for what one project has been doing. And then that brings and connects also to regulatory aspect, who should lead this process. And there can be dictionary, can be ontology, but we need the governance. And that's a very critical point. And then that's probably linking very well to what Mark was saying in the very beginning of what the D4E process is doing. A last aspect of the discussion, and given the context right now, not a secondary, is AI. We heard from the beginning also Mark had some reference to AI and saying that there is another chicken and egg problem. We need AI, but to have AI, we need data. And we need data interoperability to train AI, but we are actually trying to reach data interoperability. So we enter in another difficult circle of discussion. But I think there was a kind of consensus that AI can help. And I also had the impression that there was an agreement on saying that it's not the solution, but it can accelerate and but not replace other solutions, particularly because in our field processes are quite clear. But AI nevertheless can help, for example, also in this reasoning part. So maybe in the discussion dictionary ontology, there comes this third option of AI, particularly Gen AI, as a way to add reasoning, overcoming some of the challenges in data interoperability. It was actually pointed out by Elisaios that there are more use cases for AI, but as we heard from Mark, right now the challenge is to train so that we can really find a way to have foundation models that can be adequate for our sector. So I would say I agree with Alexander. This was a very exciting discussion with a very open comparison of opinion. And my overarching impression is a very hard question that we are trying to address in this. And as Alexander said, we could go on the whole evening. And but I think there were some very good experience, and also the interaction of different stakeholders, like bringing the energy community versus the DSOs versus manufacturers, showed how we need to bring at the table many different stakeholders because we need at the end the consensus. And what I like is that several times appeared the idea that community-driven, consensus-driven solutions, so very open approaches, are maybe the only way to bring all this discussion to a common point so that we select and define the way to achieve interoperability in the sense that we would like to achieve. I hope this was a comprehensive summary of the discussion. I want to thank all the panelists for the participation, Alexander for co-leading with me the discussion, and Mark von Stiepald also for the very interesting and inspirational opening speech. And I thank you all for the participation. I hope you found this webinar interesting to deepen your understanding of the current situation, interoperability, and the work that different projects are doing in this direction. With that, I thank you very much and hope you have a wonderful evening.
Thank you, everyone.
Thank you.
all.
Thank you.
Many thanks. Have a great day, bye.